morning, guys. This is Luigi Pagliarini, and I will try to give you a very modest and simple, I hope, introductory lecture on the interconnection between robotics and art. In what we can call in a Playware context, in a context which will lead to the idea of Playware evolution in the artistic world. But before that, let's talk about the interconnection between art and robot, since these two fields they are apparently disconnected, but in reality, in the history of robotics and art, there is a strong link and a strong parallel evolution, which make it so that the scientific work and the artistic work drive together towards the evolution itself of the idea of robotics and of robotics into our society. Me and myself and Professor Lund, we've been working a lot around that. And well, I'm quite sure I have no time to show you how much things we've been working at in this little domain, which try to speculate in an artistic way how the Playware and robotics more in general can be evolved together. To show you the relationship between art and robot, we must start from 1920, when a playwright, Mr. Karel Čapek, defined the idea of robot in his play Russian Universal Robots. So the robot comes from the artistic, the idea of robot comes from the artistic world and was interpreted at the beginning as the mechanical thing, the automated things, which was meant to play and to make the hard work of life. After that, so as you can see, there is a strong interconnection since the beginning between robots and art, and in this chart you can screen dump if you want. There is a kind of the road, the interconnection between robotics and art was developed from the first the pioneer attempts of Leonardo da Vinci or up to 1976 here. After the Karel Čapek definition, and we all know that in 40s the work by Isaac Asimov has been influencing the society quite a lot. There were many books he wrote, and iRobot probably is the most famous one, in which he defined the famous three laws of robotics. So as you can see, the even the idea of interconnection between robot and human society was kind of influenced by the artistic world. Then again, later in the 50s, the one important artistic project which kind of changed the idea of looking at robots as something very interconnected with human beings was given by the Gutai Project, Art Association, which created the electric dress in 1955, and the electric dress was a kind of wearable robotics, a wearable architecture in electronics. Here I think there is a short video showing you the reenact, not the real thing, but the reenact, which is still presented in a Japanese museum. Again, in 50s, the very first sensory motor machine, which saw basically a robot, was created by Nicholas Chopper. It was called CHISPS 1, which was considered the first spatial dynamic sculpture. So a sculpture with which was able to move based on sensory actuation. And this is what we call autonomous robotics today. Okay, so it's not important that you remember details, but just the concept that both the aesthetics of some robotics and the functionality of robotics have a lot to do, as well as the philosophical approach has a lot to do with both the fields of robotics in meaning science and robotic meaning arts. Again, a big jump in the 70s was pushed by the steampunk culture, which was an artistic movement. Later on, the steampunk was replaced by the cyberpunk, which I guess you know quite well, by Gibson and other authors. So the steampunk culture showed the idea of interconnecting calculation with the human body. Of course, the steampunk has as well a specific aesthetics, as well as the cyberpunk will have. Then, keeping the track on exoskeleton, the very first impressive robot art experiment was shown by the famous Stellark, an Australian artist, which has been implementing this spider shape exoskeleton guided art piece. Let's see if I can find the video. Stellark. Exoskeleton, as you can see here, and this is quite impressive and very interesting. So, as you can see, in 90s, artistic experiments were leading some new ideas, as well as in Marcel Lee work. Let's find it, Aphasia, in which the idea of exoskeletons and multimedia projection were interconnected in such a way that the artist movement had a kind of storytelling developed by the movement on the stage themselves. Very interesting.
Un, dos y tres.
Gracias, muchas gracias.
So it is nice to see how the two fields talk to each other. This is a quite recent experiment showing, let's see if I can find it.
僕の子犬がいなくなった白い足白い尻尾ずっと
Okay, showing how artists always try to interconnect the technology with an idea of aesthetics. Of course, those kind of intuition were applied in a very scientific way, as we can see here. This is from military.
Pull down, no sweat. We did this 500 times until we got bored, so I could basically do it, ad nauseum. And you're not even out of breath now. No. Not out of breath, not weary, no muscle.
Very, very interesting. And in medicine, as you can see.
Shoulder up, elbow straight, elbow back, shoulder down, elbow down.
Are you actively closing the hand, or are you just not doing anything with the hand?
I'm not doing anything with it. Just press the hand. Kathy wants me to keep it closed, and I'm going to open it. Keep it open.
Okay.
Elbow down, shoulder up, shoulder down. Got a little rotation in there. We'll work on that. Elbow up.
Take the hand part way. Oh, great, Jesse. Great.
Wax on, wax off.
Nice.
Come on. Paint the
Wax
fence.
on, paint the fence.
That's it.
Wax on, wax off. Wax on, wax off.
Sand the floor.
Sand the floor.
Which one's on the floor?
Where's the sand at?
These principles we try to apply also in the Playware context this idea of wearable robotics, and we applied those design principles typical of the Playware. So behavior, motivation, immediate feedback, adaptivity, modularity, and so on, as tangible interactions. And we try to build a wearable robotic system very similar to what you saw with the idea of that we were manipulating and sensing the body state, the motion capture, the feeling capture, and interfacing it with different hardware. And my idea was of applying to tissues electronic circuits, and this is the thing. And we had many different models. The head, the shoes, the gloves, the spine, the heart, sorry, and so on. Here you can see the head with many circuits. You see here a battery, a sensor here, and whatever. Building what I called the fatherboard. And the idea was to have many different modules, which could be sometimes some of them were fixed, some of them were interchangeable, so you could test the idea of module in different parts of the body. And I created this super avatar I called. Here you can see a short clip. In a theater context. That was very kind of appreciated by the world of art. This is the idea of module to be applied with clips in in different parts of the body. So, what I'm saying is that the idea of modularity can be applied. Of course, in art we have different goals, and as you can see in this example, art doesn't really care about functional um, identification or idea of robotics, but it concentrates on the aesthetic part. For example, in this little video here, you can see what they call the most useless machine, because the artistic approach, after all, is a speculating approach in which that's the biggest difference between science and art. Is not a technological difference most of the time, as a simpler idea to use things the way they are without caring about functionality. And this is very nice, because it's a kind of a complementary approach to what you do in science, in your engineeristic field, in engineering. Therefore, this is, let's see if we can see now. This is let's see if I can find it. This is another example. Artists, they also kind of exploit what errors. They like errors. So in the artistic poetics, not only useless thing, but also we use potential errors from scientific ideas to implement artistic expression. And that's very funny. That's very artistic, no? The idea of finding the balance between technological application.
It's actually going to work, I think. Oh, there we go. Right him in the hole. Oh, right him, cowboy. Oh, boy. 8 seconds. 8 seconds is what we're looking for. He is now blinded and mad. I can't get
Okay, so this is just to integrate your view. What I want to say is that maybe a nice way to see things is not to kind of think of art and robotics as two different fields. This is art and science more than art and robotics. Is to think of the two things as the same expression of the idea of progress, in which the different approaches are applied. So this is this idea that art and science are separated, are contraposed. It's a very recent thing. It came from it came from Renaissance. I don't know why. Probably for religious motivation. Um, at a certain point, the idea of art was separated from the idea of science, but they're both belongs to the concept of innovation, research, and progress, if we want to call it so, in society. So, what I want to underline first is that art and science are the same thing to some extension. Second, I wanted to show you how one pushes the other and vice versa, and that is very important to know, to understand, and even to appreciate, because the two branches of the human thinking, they pushes different aspects, but they belong to the same kind of progress and evolution in concept. And third, I wanted to show you how you can easily apply the concepts deriving from the Playware model of thinking can be applied both to science and to art, to shows and to research itself. Okay, so I hope that this might now give you can facilitate your idea of thinking of robotics and Playware as two things which belongs to the same evolution. This is one more example to say you hello.